What will be the value of a number that has the exponent 0? Imagine we have an arbitrary number and let's denote it with a, and a can be any integer but not 0. Suppose this a has the exponent 0. What will be its value? Let's understand this here. Let's take one power, that is 7 to the 5th power, and let's take another power that is exactly the same to this one. So another one is again 7 to the 5th power. This is power 1, this is power 2. We have two powers, and if we divide these two, now if we divide these two, then the second law of exponent, the second law of exponents says that if you divide two orders having the same base, the powers have the same base. So if you look here, this power 7 to the 5th power has a base 7, and this power 7 to the 5th power has a base 7. So we have the same base, right? So the second law of exponents says that if this is the condition where you have two powers having the same base, then you simply write the base, and then from this exponent, that is the exponent that is in the numerator one, subtract from this exponent the exponent of the denominator one. So this gives you what? This gives you 7, and its exponent is what? 0. Now the fifth law of exponents says that if you are dividing two powers and the powers has the same exponents, in this case you have the exponent 5, and in this case again we have the exponent 5. These two exponents are the same. So the fifth law of exponents says that if you have the two powers that are being divided with each other have the same exponent, then what we do is we simply, if this is the condition, that is 7, if this is the condition, sorry, I won't take the red color, 7 to the 5th power and 7 to the 5th power, if this is the condition where exponents are the same, then in such cases you divide the two bases. In this case we have taken the same base because the bases are equal. You divide the two bases and then simply write the exponent here, right? Now what does this become? It becomes 1 to the 5th power. 1 to the 5th power means what? You have to simply multiply 1 5 times with itself. And what do you get? We get 1. Now, this 7 to the having exponent as 0 has to be then equal to 1. Because it doesn't matter whether we are following the second law of exponents or the fifth law of exponents, the value derived from this law and this law will be the same, because we are applying on the same operation here, that is the division of two powers. In one case we are looking at the same basis and therefore applying second law, but in the other one we are actually looking at the same exponents and applying the fifth law of exponents. But the value of this operation, that is a division, is going to be the same, doesn't matter which path you take. So 7 and having exponent 0 to the 0 power will be equal to what? 1. Will be equal to what? 1. Now let me take this negative 7, this minus 7. What if this was minus 7 to the 5th power divided by minus 7 to the 5th power? Again, if you take the second law of exponents, having the same basis, then it becomes what? It becomes minus 7, and this is actually 5 minus 5. So this gives you minus 7 and having exponent 0. If you take the fifth law of exponents, according to fifth law of exponents, then actually we are dividing two powers having the same exponents. So this becomes minus 7 to the fifth power, minus 7 to the fifth power, and this is minus 7, minus 7, and this is 5. This is what? 1 to the fifth power, and this becomes what? 1. And this minus 7 to the 0th power should be equal to then 1, right? So it doesn't matter whether your number is the number is positive or negative. If it is raised to 0 power, then that will be equal to 1. So if we have to generalize this, if we have to represent this in a general way, in a generalized way, how will we do this? Imagine that we have a non-zero integer, that is a should not be equal to 0, right? And if it is raised to the power m, to the mth power, and let's take again another power, that is a to the mth power, and if we divide these two, then if we follow the second law of exponents, that says if the bases are the same and if you're dividing the two powers having bases same, then this becomes what? This becomes a, that is the base, and then m minus n. So this gives you a having the exponent 0. And if you follow and from the fifth law of exponents, this is a to the mth power, and this becomes a divided by a and the exponent. So this gives you 1 to the mth power, this gives you 1. This has to be equal to this one. So this is a having exponent 0 is equal to 1, and a should not be equal to 0. Now if you are wondering why, then let me tell you that 0 having its power as 0 is actually undefined. It's actually undefined. This is undefined. And why it is undefined? Because some say, some mathematicians say that it should be 0. This value actually should be 0. And some say that it should be actually 1. So the fight is between these two values, and why and how, then it's, we'll learn this when we'll move to higher standards. But at this level, just remember that 0 to the having exponent as 0 is actually undefined. That is why we say that if any integer is having exponent as 0, this will be equal to 1, but that number should not be equal to 0. So what does that mean? If we have numbers like 1000, and if it is having its exponent as 0, this is actually what? 1. Even if it is 10 lakh, 1, 2, sorry, okay, so this is 10 lakh, even if it is raised to the 0 having 0 power, this is actually equal to 1, right? Now there is another way to prove this, that a to the 0 power is actually equal to 1. That is, any number having the exponent as 0 is equal to 1, and that I'll discuss in the next video. So let's learn another way to prove this, and we'll see you in the next video. Thanks for watching.